Hello students, welcome to my channel, Care, for concepts, for clarity, for solutions. I am ready to teach. Are you ready to learn? Let us start some questions. In the first chapter, we are seeing all the example sums before 1.1. Use Euclid's algorithm to find the HCF of 4052 and 12576. First of all, you should know about two things. One is Euclid division lemma and Euclid division algorithm. There is a slight difference is there. You can see my previous videos. When it comes to the Euclid algorithm, you have to take the sequence of steps. We have to apply the Euclid division lemma more than one time. It's based on sum. So this process will continue, the division process will continue until you will get 0. Then only it stops the process. Let us say this 12,572, 12,576. We are dividing with the number 4052. So I am taking 3 times of this number. So what will get 12,156 you will get. Just multiply and check it whether it is correct or not. You will able to come to know. So 0, 2, 4, 420. So this is a remainder and this is a quotient and this is a divisor and this is a dividend. All these terms you know very well. But when you are finding HCF, the remainder you should get 0. But we are getting here it as a 420. So we need to continue the process. This 420 now it becomes as a divisor. Now 4,552. So we are replacing here. This becomes now new dividend to us. What is it? New dividend to us. So divide with 9s. It will go by 9s. 429s are. So 0, 18, 37. I want to write clearly it is. So this is 0 and 18 means 1, 4, 9 are 36, 37. 3,780. Subtract this 2, you will get 7. And here 39 minus 37, you will get 272. So again, the remainder is not equal to 0. Continue the process. 420. How many times? It will go by 1 time. So 272. Subtract this. We are getting 8. 11 minus 7. It is 4. And this is 1. 148. So new dividend becomes 272. Again it go by ones, so 148, subtract this, 12 minus 8, 4, borrow, so 24, 124. Again we need to continue the process, 148, it goes by once, 124. So 4 and 24. Still need to continue. 124, 24 5s are. So this is 120. So I written as wrong here. So what is this? What we are getting new dividend. So this is 124 How many times? It is go by 5 times. You are getting 120, 124, 24 5 is 120, 4 as a remainder, still need to continue 24. So 6 4s are 24. Here you are getting 0. So we need to stop the process. Now, when you are getting 0 by dividing with 4, so this 4 we can call it as HCF of this number. So this is the process. Same thing we can write like this also. So same thing, what are the steps what I have shown earlier, we can write in this way. So ultimately you are getting 4 as a remainder, and that 4 is HCF of this problem. So next example, show that every positive even integer is of the form 2q, and that every positive odd integer is of the form 2q plus 1, where q is some integer. So for this type of questions, we have to decide the b value. A is as it is, you have to take b as equal to as 2. Based on the question, b changes. For this question, if you take b as a 2, and if you apply the division lemma, as you know that a, if you divide with 2, you will get some quotient and you will get some remainder. So a can be written as 2q plus r, divisor into quotient plus remainder. So these concepts you know earlier. If not, you can see my videos. A is equal to 2q plus r, and r takes the values, it takes 0 but not b. But b here it is 2. I can written as here it as 2. It takes 0 but not 2. So what is the meaning of 0 less than or equal to r less than 2? So r takes the values 0 and 1, less than 2 means it is 1. So r takes the values of these two. So these two values, if you substitute in this equation, so put r is equal to 0 in this equation, a is equal to 2q plus 0, a is equal to 2q. Similarly, I am putting r is equal to 1 in the same equation. So this is the equation I am putting r is equal to 1. A is equal to 2q plus 1. If you repeat this, a is equal to 2q. Q is multiplied with 2. So if any number, any integer multiplied with 2, it belongs to even number. It belongs to even number. So here a is equal to 2q plus 1. So this is the odd number. If you divide with 2, you are getting the remainder as 1. 2q, whereas 2q is nothing but completely divisible, 2q plus 1 means you are getting remainder 1. So this belongs to odd number. So this is a odd number. So as simple as that, even numbers in the form of 2q, odd numbers in the form of 2q plus 1. Overall, I will brief this one. So any positive integers in the form of even numbers is in the form of 2q, odd numbers is in the form of 2q plus 1. Let us take a and b are two numbers. Here we take b is equal to 2. This b is equal to 2 is very important. Why you are taking? This b changes from 1 to 1 sum. So if you apply the division lemma, a divided with 2, you are getting some quotient and some remainder. If all this process, if you write it in the equation form, a is equal to 2q plus r, where r takes the values 0, not 2, in between 0 to 2. So here r takes the values 0 and 1. This r values, if you write in the equation number 1, so you are getting a is equal to 2q plus 0, that is nothing but 2q. 2q is nothing but, that is a form of even numbers. Next case, if you keep r is equal to 1, a is equal to 2q plus 1, these are odd numbers. Odd numbers in the form of 2q plus 1, 2m plus 1. You know very well of this sum. This is all about the sum. So let us see another example. Show that any positive odd number, odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. So consider a value and b we are deciding as a 4. How you got the idea? So that is depends on the question. Based on the question, here it is in the form of 4q plus 3, 4q plus 1. Based on this, you will get some hint in the question. You have to decide b is equal to 4. Sometimes b is equal to 2. Generally 2, 3, 4. Not more than this. That is based on the question. If we apply the division lemma, so a I am dividing with 4. You will get some quotient and you will get some remainder. So all this I am expressing it as a is equal to dividend is equal to divisor into quotient plus remainder. So where r takes the values less than 4, but it takes 0 also. So this is, I applied the Euclid division lemma. Let us write r what are the values r takes. It takes 0, it takes 1, it takes 2, it takes 3. Why? Because of r is less than 4. R is less than 4 means up to 3 it takes, not 4. Now all these values you have to put in the equation. So this is I am writing it as in the equation number 1. Put it in the equation. So I am slightly dividing 4 parts. So put r is equal to 0 in the equation. So what we are getting? A is equal to 4q plus here it is 0. So a is equal to 4q. Similarly, we can put r is equal to 1 in the equation number 1. A is equal to 4q plus 1. So we cannot further simplify this, leave it. Similarly, put r is equal to 2. So a is equal to 4q plus 2. And lastly, r is equal to 3. If you substitute in the equation number 1, you are getting a is equal to 4q plus 3. So a takes different forms. Here it is a 4q. 4q plus 1, 4q plus 2 and 4q plus 3. In the question, he has given to identify the positive odd numbers. This is a very important. Positive odd integers. A is a positive odd integer. So 4q, it can never be odd number. Why? Because of, odd into odd, odd even into something, always even number. So this is belongs to even number. I'm writing even number. Come to this one, 4q plus 2. I can take 2 common here. If I take 2 common, so I can write it as 2q plus 1. So multiply this 2 into 2q, 4q and 2 into 1, that is 2. 2 into something I wrote. So 2 into something means again this is a even number. But which numbers you want? You want only the odd numbers. You want only the odd numbers. So therefore A is equal to 4q plus 1 or A is equal to 4q plus 3. These are the odd integers. Remaining 2 are even integers. So that's all about the sum. This is the last example in this exercise. Before 1.1. Sweet seller has 420 kaju burfis and 130 badam burfis. We have 2 types of burfis here. One is kaju. I am writing it as KB, kaju burfis. How many it is? 420. And badam burfis. Badam burfis, it is 130. So 2 types of sweets she is having. She wants to stake. Stake is nothing but a kind of tray. She wants to keep in a tray such a way that each tray has same number and they take up the least area of the tray. What is the maximum number? In the sum, whenever you are getting the maximum number, so indirectly he is asking HCF of the 2 numbers. What is the maximum number of burfis that can be placed in the tray for the purpose? So we will find out HCF of these 2 numbers. HCF of 420 and 130. So we have to divide 420 with 130. It goes by 3 table, 3 or 4. 4. I think 4 it is never goes 3 times. So 390. So what you are getting 0 here and 30. So remainder is not equal to 0. We continue the process and we will divide 130 with 30. How many times? It is 3 times. We are getting it as a 90. Okay, I will take it as a 4 times here. So 4 times of 30, that is 120. We are getting 10 as a remainder. This becomes new divisor and new dividend is 30. So 10 3s are 30. So ultimately you are getting 0 and you have to stop the process. So when you are getting 0, when you are dividing with the 10. So this 10 will give the answer for this sum. She wants 10 stacks, if not 10 trays to keep the these two types of buffer's in the smaller and maximum number of buffer's we can keep in this trace.